So this is a question that a lot of you asked about today, number 8. First of all, it's just the cosine rule. So we've got to calculate angle BCA. So I'll just label that one. There it is. It's cosine rule. When we're recognizing it, it makes we're trying to find that angle. It's a trapped angle. We know both sides either it, so it's a croissant. So that's the cosine rule. So you could go to your formula, which you've got here. So you're given that, remember, in the formula booklet or in the formula sheet at the front. But you might want to, best thing you do is probably rearrange it to make cos A the subject, because you're trying to find that angle. So the formula is a squared equals b squared plus c squared minus 2bc cos A. I'm just going to rearrange that to make cos A the subject. So I need to move all of that to the other side, and I'm going to swap it with this one, which I'm going to move to the right hand side. So they're just going to change places. So I've got 2bc cos A, all of that moving it as one number, and then subtracting a squared from both sides, the angle that goes with cos A, and then just divide. So you can memorize this, that's fine. Remember, you're not given it in this form. And then divide by 2bc. And I recommend doing that because you get 2 method marks if you then just substitute, or if you write it in this form. So let's substitute in. So what I've got is my corresponding side and angle is this one. So this is the angle, which is opposite side 16. So they're the matching pair. So that means it's going to be cos of angle ACB, or ABC, or BCA as they've shown it there, is going to be the sum of the 2 sides, which aren't the opposite angle. So it should make them easy to identify. So it's 18 and 13 are the 2 other ones. So 18 squared plus 13 squared, minus a squared, which is easy to find because it is the side which is opposite the angle that we've got. So that's how you can differentiate between the 2 or 3 sides, 2 that go together, and the other one is actually opposite the angle that you want, or the angle that you're given. And then divided by 2 times 18 times 13. They're the 2 sides in the trapped angle. And then you can type that into your calculator, find inverse cos, and you should find that the cos of angle BCA is equal to 79 over 156. If you evaluate all of that, and then if you find inverse cos of that, so, and we work out angle BCA, then we'll find that the angle is this. And I would put all of that in, keep it as many decimal places as possible, because then you can show that it rounds to 59.57. So then you could write again that would round to 59.57 degrees as required. And then you've shown that that's true. The area of the quadrilateral, this is another absolutely classic question. Let's get rid of all this nonsense. You've got 2 triangles, basically. You just have to find the area of both of them and add them together. So I'm going to call that the red triangle. And I'm going to call that the yellow triangle. So red triangle is triangle ADC. And the first part, that is fairly simple. It's going to be 63 centimeters squared, because it's just a half base times height. This one's a bit more complicated, because we're going to have to use this formula to work that out. We're going to have to use the formula for the area of a triangle there, which we can access fairly easily. And here we need a trapped angle, and we've got one because we've just worked out an angle. So we worked out angle BCA, which is here. So the angle is trapped by sides 18 and 13. So it's simply a half times 18 times 13 times sine of the angle in between them, which is 59.57. So if we do that and just type it into your calculator, you should get 100.888, and then you just add together the two triangles to get the area of the whole quadrilateral, which to three significant figures would be 164. Moving on to the next point, this is quite a common question. I've seen this come up quite a lot. Find the shortest distance from A to BC. Let's have a look at what that is. So from A to BC, we'll be going down there. And it's important to remember or recall that the shortest distance would be at right angles to the point. So if you go kind of either side of that, it's obviously going to be a longer distance. So you're looking to create a right angle triangle. And where there are right angle triangles, there's SOHCAHTOA and there's Pythagoras. So we know we're trying to find that blue line, so I'm going to call it whatever, X. We got that angle because we've worked it out. We keep using it, BCA. And you got this length here. So we can use SOHCAHTOA. We can use right angle trig. You've got a side and you've got a angle, so you can work out the other length. We just got to label it. So we're trying to work out X, but we go opposite the angle, so that is the opposite. The hypotenuse is the longest side, and the other side, which we don't really care about, is the adjacent. And which one we use? We can use SOHCAHTOA. Well, we're trying to find the opposite, and we've got the hypotenuse, so it's O and H. Well, that didn't take long. So we're using sine. Sine of the angle, so is equal to the opposite X over the hypotenuse, so which I've written there, and now we're just going to rearrange and solve it. So if I do that, I times both sides by 18, so 18 times sine, 59.57, etc. should be 15.521, which rounds to 15.5. The diagram, you can see that is the shortest distance between A and the line BC. This question then is quite tricky. It is D is due north of B, find the bearing of B from C. So I've drawn this already. If B is due north of, D is due north of B, that makes sense, then it's a straight line between the two. So it would just go straight up from B to D on the north line. And we've got to find the bearing of B from C. So starting from C, so you're going from that point, you would measure from the north line, as I've done here, clockwise, until you stop at the line here, which is going to point you in the direction of being able to get to B. So you're looking at that green angle there, green bearing. Helps us with the question, is this triangle here. So we now created a new triangle. That red part there is on the north line. This is useful is if we can work out this length here, this new length on our new triangle, which is on the north line, I'll call it, I don't know, Y. Then work out this angle here, which is going to be the key to everything. We can work out that angle because you can use sine rule. So you'll have that length paired up with that angle, and you can have this side paired up with that angle. We know that angle because it's the right angle plus the angle we found already. And then if you find that blue angle, the one I've highlighted at the bottom there, you can then use angles on parallel lines because that's a Z angle, an alternate angle, sorry. So this angle here is a Z angle, alternate angle. So that means that blue angle is going to be the same as this blue angle because they're both on north lines. So when you have two sets of north lines next to each other, you can start thinking about using angles on parallel lines as well. Why is that useful? Well, I hope we can see by now, because that means we know that's 180 degrees from here to there. So if we add on that little blue angle, we've got the bearing. We've gone all the way around. So let's do that. In cosine rule again to find that length Y. So we know this angle and it's opposite this, which we're trying to find. So that's why they're paired. We know that angle, I'll repeat, because it's 90 degrees plus the angle that we were given, to be honest, here, so 59.57. And then the trapped, it's a trapped angle, so the other sides that go with it are 7 and 13, which we can just use here. If you're more comfortable using the formula, that's fine, but you know, after a while you just get used to how it matches up. And that, if we rearrange that, we'll find that y is equal to 19.363. Just to make sure you're aware there, I think previously I wrote plus 2 times 7. Of course, with a cosine rule, it's minus that, so apologies, I've corrected that. To use the sine rule to work out this angle here, theta, that's going to help us. I've just labelled it theta. And I set it out as so. So you've got this angle here, matching up the opposite side here, which you can see here. So it's sine 149.57 over the side we've just found. And then the other matching pair is the angle theta that we're trying to find is opposite side 7, which I've written there. And if we do that, you know, you can do that by rearranging, just multiplying by 7 and then finding inverse sine of what you've got, or you could use nsolve, or, and we should get 10.55 degrees. So that means all we have to do then is add that on, because that is, as it's an alternate angle, it's going to be the same as that purple one I've just highlighted it. You just do 10.55 added on to 180 degrees, because all of that line there is 180 degrees. Which will give us our final answer then, if we added them together, 191 degrees.